that is basically motion, oscillation and motion. Okay, oscillation and simple harmonic motion basically. Is this visible to everyone and audible to everyone? So, okay, moving on. So when we talk about oscillation and simple harmonic motion, basically that topic is an independent topic. I can say there are small chunks of uh, electromagnetic induction included in this topic, but that will be in the damped oscillation. So where I'm going to tell you about the damped oscillation. In fact, here most of the topics or most of the points are those points where I have this entire data as the free oscillation. Okay, and this free oscillation is basically that oscillation uh, which has all the kinematics included. So I will talk about that all, and hopefully this will be discussed with you in detail. And after that damped oscillation or forced oscillation, after that we will be talking about damped oscillation and forced oscillation. Okay, ji? So here is, let me open up that file which I have just shared with you. There is some problem in the files. Just a second. Assalamualaikum, Yaya. Hello, Yaya, how are you?
Waalaikumsalam, sir.
Fine. Sorry, I have just saved the file. Yeah, where is that file? Sorry, sorry, sorry. We're not. Oh yes, this is that file. Open up, please. Yes, here is now open up. Sorry for this delay. Now the things are all settled down. I hope that now you people will get all that data on your screen. Okay, so when I talk about the oscillation, here the oscillation means that vibratory motion of the body. Okay, so here what I have mentioned for the oscillation means vibratory motion of the body. So vibratory motion is the motion of a body about a fixed position or about a mean position. So to and fro motion can also be considered as the vibratory motion, right? Is it clear to everyone?
Yes, sir.
Okay, so its three parts are there. Free oscillation, almost 70% questions are asked from free oscillation. Then we have damped oscillation, right? And then we have forced oscillation. So remaining 30% questions are there from these two topics. That is why I was talking about that most of the physics is derived from this free oscillation. And once we have free oscillation, actually free oscillation is the oscillation in the presence, sorry, without any resistive or driving force, right? The oscillation without any resistive or driving force, that oscillation is called your force, sorry, free oscillation, right? What is the driving force and what is the resistive force? When the oscillation will be in the presence of resistive force, that will be called your damped oscillation. Yani resistive force means there is an opposing force which basically stops or tries to stop the motion of the body, and driving force is that force which supports the oscillation, like the swing. When we are at the swing and we are being uh, pushed by the other person, then that oscillation is called over forced oscillation. And that oscillation is, why do we push the person on the swing? Because we want that the amplitude of oscillation should remain constant or it should increase continuously, right? Is it clear to everyone? Okay, so oscillations oscillation due to natural momentum or natural moment oscillation due to the natural frequency of any oscillator, that is called your free oscillation. In free oscillation, what will we do? We will have three major areas what I will talk about, and these three major areas are: one of them is your kinematics of oscillation, the second one is basically the simple harmonic motion of the oscillation, and third one is actually the energies of oscillation. So these 3 points are very important. We will talk about these 3 points in detail. So I hope that this topic will be quite interesting for all of you, because I already have written all that. Okay, ये मैं पीडीएफ भेज भी दूंगा, मसला नहीं है, अगर आप आराम से इसको। जी, ठीक है, ठीक है, ठीक है, कोई इशू नहीं, कोई इशू नहीं, ये लो, आराम से लिख लिया। ओके, तो देखो, इन काइनेमेटिक्स ऑफ ऑसिलेशन, काइनेमेटिक्स मींस देयर आर सेवरल terms which you are familiar with, that is displacement, velocity, acceleration, and all that stuff. So displacement is a part of kinematics, velocity is a part of kinematics, acceleration is a part of kinematics. So these are all basically the points which we usually now in terms of kinematics. And here we will talk about displacement and time, velocity and time, then we will be talking about acceleration and the time, and then we will be talking about velocity and position, and we will talk about acceleration and position. So in this kinematics, we have all these areas what we have to discuss. Got it?
Yes, sir.
Okay. So once we have this entire concept of oscillation, means that this will be just just view. Okay. Yes. I'm just trying to show you the full screen of this. I hope that it would be. No. Oh my god. Minimize. Yeah. Okay. Now it is fine. Okay. Now is it visible? Okay. 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 So actually, before that, I was trying to set it down, but there was some problem in the screen ratio. Okay. So these all are the points I will discuss in the oscillation. So I hope that they are clear to everyone. Are they? अब देखो,
Yes, sir.
first of all, we will talk about displacement. What does it mean by displacement? If I say displacement is represented by x in the kinematics, sorry, in the vibratory motion, then it is the shortest distance between 2 points. What is the displacement? It is basically the shortest distance between 2 points, right? So if we have 2 points and we are going to discuss about these 2 points, are we can simply say that yes, if the displacement is between 2 points, so that is the shortest displacement, in fact. So here, the shortest distance between equilibrium position and the point at any other position other than the extreme. I will explain this in the diagram here. Let's see. Here is the diagram. Here I'm going to explain the displacement to you. For example, if you see that the object is here, this is the equilibrium position, and here I have mentioned all that stuff. Equilibrium position is here. From the equilibrium position, this is the point from where the object returns back to its original direction of motion, and it reverses the direction of motion. So that is why this position is your extreme position. What do we call it? This is your extreme position. So the displacement from equilibrium position to the any of the point other than extreme, that is called displacement. And Amplitude is basically the displacement between equilibrium position and the peak point, any extreme point. This is actually, this one is the amplitude, right? What is that? This is your amplitude, and this x is actually your displacement. Okay, so I will show you that what I have written for the amplitude. Amplitude is basically the maximum displacement between equilibrium position and extreme position for a body, that is called the amplitude. Okay, is it clear to everyone?
Yes,
Okay,
sir.
now we will talk about that if I have an object, on that object x will be equal to x naught if it is at extreme points, right? When that object is at extreme point, then its x is equals to x naught. Then its x is equals to x naught, otherwise not. Okay, sorry, I was just reconnecting with my connection. So here x is equal to x naught at extreme point, where x is basically a vector and x naught is a scalar. Displacement is a vector and amplitude is scalar. This is important point here. So in this diagram, the diagram I have shown you uh, uh, here, if I have taken the example of a simple pendulum, this is its equilibrium position, and at this equilibrium position, from this equilibrium position, there is a dotted line. If you see this dotted line, the displacement from the equilibrium position to this dotted line is x, and displacement from this equilibrium position to the extreme position, that is x naught. So the upper explanation that was basically from the wave, and this explanation is from the real time diagram of an object which is oscillating. Okay, is it clear to everyone? Now there is no derivation of all these equations which I have shown to you. That is the equation of displacement, velocity, and acceleration. These all are the equations which are there in your syllabus, but they do not have the derivation. Okay, okay. So when they do not have derivation, so can we say that x is equals to x naught sine omega t? That is basically its first equation which you have to recall for the displacement versus time. Yani here in this equation, displacement is actually what? Displacement is a function of time. Yani I can simply tell you that the problem in this entire setup is that if I have an if I have an object which is basically having displacement, then that displacement can be studied with respect to time. How? Because that displacement is the function of sine and time. So that is why x is equal to x naught sine omega t is its equation which will represent that displacement. Now, depending upon this equation, because I told you that I have not put in any sort of derivation in this, because we have to recall and use that equation. So you have to recall this equation: x is equal to x naught sine omega t. Okay, will you be able to recall that?
Yes, sir.
Okay, it is x is equal to x naught sine omega t. Now, what is important in that? Okay, let's say we did that, x is equal to x naught sine omega t. This all is there, but there is another issue. That issue is how I will manage this equation to figure out the displacement at any of the instant. Okay, at any of the instant. So how can I manage that? Can anybody tell me? I will put the values of time here. Okay, what will I do? I will just put the values of time. So when I will place the values of time, basically that time will tell me that when the what is the value of displacement. Here, did you see it properly? That x is equals to x naught sine omega t is the equation, and that equation will help you out to figure out this entire calculation. How? Let's say I want to find out the displacement at x is equal to at time t is equal to 0. When time t is equal to 0, let's do it here. At time t is equal to 0, I will place the value of time t, yani t is equal to 0 in this equation here. Instead of t, I will place 0. So which value will be for acceleration? What will be the value for acceleration? Can anybody tell me? Yes. हंजला हंजला जब टाइम 0 होगा तो साइन 0 क्या होएगा? What will be the value of sin 0? नहीं 2 pi by 0 नहीं. This entire value will become 0 then, right? This entire value will become 0. Remember this thing. Why? Yes, it means if I show you this diagram at time t is equals to 0, the object has no displacement, isn't it? Okay. For example, this entire graph is for 4 seconds. Yani total, what is the time period of this object? Oscillation time period कितना है? Yes. What is the time of oscillation? Yani period of oscillation. That is 4 seconds. Or sorry, 4 milliseconds. I have shown you 4 milliseconds. Now, if I want to find out omega from here, omega is equal to 2 pi by t. And when omega is equal to 2 pi by t, it will be equal to 1.57 radians per second is its angular speed. Now, here, move on. I will plug in all these values, right? Here, that if the now the equation is x is equal to x naught sine 2 pi by t. Instead of omega, I'm writing 2 pi by t. Here, that is visible to you, 2 pi by t, and here 2 pi into small t divided by t. So actually now I will place the values of the time accordingly. For once the time is equals to 0, your displacement was 0. But now let's say at time t is equals to 1 second, when the time is 1 second, how much displacement will be there? Let me put the value here at x is equals to 20 sine 2 pi by 4 into. Yes, I am just going to find the amplitude at 1 second. Okay, 1 second. So I will place the value of time 1 here. Okay, please calculate this for me. What will be the value? X naught की x की वैल्यू क्या आएगी? 0 पॉइंट. ओके, कैलकुलेटर रेडियन में है डिग्री में है? Okay, for
Sir, I
this,
got 20.
yes, once your calculator will be into degree, for this value, sine it will be sine pi by 2. So sine pi by 2 matlab 20. Okay, so you will get this value that is equals to 20. Okay, is this clear to everyone? अब देखो, here we go. Check this one out. At after 1 second, this is yani 1.0 millisecond, let's say. At 1.0 millisecond, how much or what is the amplitude of this wave? Check this one out. 20 millisecond है ना? Is it? Are you getting my point? Got
Yes,
it?
sir.
Now I have given you an example. For example, if I want to find the amplitude after 1.5 milliseconds, 1.5 milliseconds. So here in this all data here, I what will I place? I will find out the displacement. The displacement is equals to x is equals to 20 sine 2 pi by 4 into 1.5. So what is the value I'm getting? Almost 14 centimeter. I have calculated that. So 14 centimeter is actually this almost this value. Okay. Are you getting this point? That what does this all show? The relation and everything? Yes? Is
Yes, sir.
this slide clear to everyone?
Yes, sir.
Any confusion or anything you want to ask me from this slide?
No, sir.
Okay, now, right after that, I will be talking about velocity. First of all, what I want to tell you from velocity, that velocity is basically rate of change of displacement. What is velocity? Velocity is rate of change of displacement, right? When it is rate of change of displacement, I can simply say that it is equals to x naught sine omega t divided by t. Okay, is this clear to everyone? What is the displacement? X naught sine omega t. X naught sine omega t is the displacement. Okay, is this clear to everyone?
Yes,
Okay,
sir.
now move to this uh, derivation part. Actually, there is a derivation. If there is a student of mathematics, you must know about this all. That once we derivate sine theta, then what do we get? We get cos theta. Is it? Then derivative of sine equals to cos. So that is why this derivation is, I have not added the derivation here in the in this discussion because that was not asked to you, that was not in the syllabus. That is why I just directly put the value that the equation tells you that this is equals to x is equals to x naught omega cos omega t. How many of you are aware of derivation? So I can show you one of the derivations. Yes, how many? Is there anyone who is not aware of the this concept derivations, derivatives?
No, sir.
Yes, yeah, yeah. You are aware. You are taking further maths and you are not aware, huh? Wow.
I meant, yeah, I am aware. I meant
Okay,
that.
okay, 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 okay. Sorry, sorry. I thought that you are just kidding with me, yes, sir. I don't know how to derivate it. Okay, is there anyone who is taking maths?
Sir, just normal math or further math.
Oh, okay. Normal maths is
Oh,
fine. Okay, so let me solve it for you just for one step. Sorry, for one equation. For the next equation, I will just refer this equation over there. Actually, this equation is this derivation is how we know that v is equals to d by dt of x. Derivative of displacement is velocity. In your mechanics, I think you have used this concept. So d by dt of x naught sine omega t, and that gives you d by dt and derivative of t. So x naught is common. X naught is basically your constant value. So you will take this out. So you will apply d by dt at sine omega t, and here it will give you x naught sine omega t. Okay, till this point is sorry, x naught cos omega t, sorry, because d by dt and derivative of sine is cos and derivative of cos is negative sine, so that is equals to cos omega t. I don't have any clue to prove it because I'm not a maths teacher, by the way, but we know that sine is derivative of sine is in converted into cos in this way. Now there is a problem. This is basically an inner function, so I will apply the derivative on this one here. So when I apply the derivative over here, this all x naught cos omega t, that is already derivated, and this will be omega will be taken out, and it will be written dt by dt, which is then cancelled out, and you got this number as x naught omega cos omega t. That is basically what your v. Is this clear to everyone?
Yes.
Yes, sir.
Just for your concept, you can use it. Otherwise, it is not asked to you. I told you it is not mandatory. It is optional. Okay. So moving on. Check this one out. You got this equation. This is v is equals to x naught omega cos omega t. So I was showing you this slide. So at this slide, this it means that velocity is the function of cos of time. Yani cos of omega t. So cos omega t means that the value of cosine graph, or you will have a graph like a cosine graph. Just look at this. The red one is the graph of your sine, right? What is the red one? Red one is the displacement time graph, and the black one is your velocity time graph. So again, mathematics helps us out that if I have a cosine graph is, or the graph with cos theta, that starts from maximum. So I can simply say that the graph which is basically mentioned here, that graph is v is equals to v v is equals to x naught omega cos omega t. Yani that graph is basically cosine graph, cos graph. Is this clear to everyone? Hmm? And the graph what I have here, x, in that x is mentioned here, x is equals to x naught sine omega t. Yani this graph is basically your sine graph. Okay, so are these points clear to everyone? Okay, so moving onward, here I have just mentioned one more point on the slide. V is equals to x naught omega cos omega t, where x naught omega is the constant which gives us a maximum velocity, right? What is that number? That number is your V max. So it means as I was having an equation that was equals to x is equals to x naught sine omega t. In the same way, I have another equation v is equals to v naught or v max cos omega t. You got this point?
Yes, sir.
Okay. So here I have some more things to show you in this slide, that v max is equals to x naught omega, and omega is again 2 pi t. So I can find out the maximum velocity if I have 2 points x naught and t. If I only have these two things, I can figure out the maximum value. Any question? Okay. So you have to recall these these equations. Now I have the masterpiece of all this, that the acceleration. Okay, this is okay. Let's start in this way. Is this slide visible to everyone? Acceleration. So acceleration is basically the derivative of velocity. The derivative of velocity means this acceleration will be equals to a is equals to minus x naught omega square sine omega t. This is the derivative, or sorry, this is the equation of your acceleration, where again it is shown that the acceleration is the function of sine but with a negative sign. So yani your graph of the acceleration would be something like this, negative sign graph. Okay, so this equation is again important, x naught omega square sine omega t. So here we go. If I say that your a is equals to x naught minus x naught omega square sine omega t, so that x naught omega square is your maximum acceleration, and this is the most important thing for my simple harmonic motion. I will talk about this point more frequently and more deliberately when I will be reaching to the simple harmonic motion. Okay, so it means the maximum acceleration is equals to x naught omega square. Maximum acceleration is what? X naught omega square. Is this clear to everyone? Okay. Now let's see these graphs. Are they all visible to you and you are able to get these graphs? Yani, are they understandable? Actually, here the graph what I have mentioned with x, that was equals to x naught sine omega t. What was that graph? That was actually equal to x naught sine omega t. That is why it is a type of sine graph. It is equals to x naught sine omega t. Okay. What about the other graph? Cosine wala graph? Yes. It is x naught sine omega t. This was equals to x naught omega cos omega t. And what about this graph? This is the acceleration graph. So that is equals to a into x naught omega square sine omega t. So these three graphs and three equations are basically correlated with each other. So if you know these graphs, you will know about the equations. And if you know about the equations, you will know about the graphs. Okay. Is it very clear to everyone?
Yes, sir.
Okay. There are three T's here on the x-axis. One T is red, that is for displacement. Second T is purple, that is for velocity. And third T is, sorry, that is second T is black, that is for velocity. And third T is purple, that is for acceleration. So I have mentioned all these points on a single graph. Okay. Here, the acceleration versus position. This is a very interesting point, really. Before this, I told you about that acceleration can be varied with time. Now here I'm talking about that acceleration is varied with position. Acceleration is varied with position. I will have a just a simple concept about that. Okay, come to this point. First of all, I will show you this slide. What do you see from here? X is equal to x naught omega square sine omega t. That is the equation. Okay, got it? Now, what do you see on this slide? You know x is equal to x naught sine omega t, and from here sine omega t is equals to x divided by x naught. So I have replaced the function of time with displacement. Now I will replace it here. Instead of this sine omega t, what did I do? I put x divided by x naught only, and x naught is cut by x naught. So what did you get? You got x is a is equals to omega minus omega square x. This all. Is this clear to everyone? This is
Yes,
very
sir.
important equation that defines the simple harmonic motion. Simple harmonic motion has lot of properties here. This that is why this is a bit condensed slide. Here I told you that the question asked about simple harmonic motion, question asked about graph or variation with the position, and these all things are mentioned in this slide one by one. For example, when A is zero, acceleration is zero at mean position, acceleration is maximum at extreme position, right? And acceleration and x are directly proportional to each other but opposite in direction. So these all points should be should be there in your mind when you are going to discuss this equation. That's what this graph. Okay, according to this equation, let's say I'm going to explain it. When x is 0, a is 0. When x is maximum, a is maximum, isn't it? So these are our two conditions: either it will be 0, either it will be maximum. So here I'm going to plot this value. Did you see the graph? This graph is of 3 marks, and it is asked why this graph is yani, how does this graph show that the object is having simple harmonic motion? That is also asked to you. So here the identification marks for this graph: it must pass through origin, it must be a straight line, and when the value of x is maximum, there must be a maximum acceleration on either side. The same should be on the other side also. Okay, so that graph should be symmetric graph. Okay, and if you have this graph, or if an object has the motion under this condition, it means that it has the evidence of simple harmonic motion, right? The object has the evidence of simple harmonic motion. Is it clear to everyone?
Yes, sir.
So this is basically what we had learned till this time. Right after that, there is a velocity position graph. I will explain that in the next class, inshallah. So you people have a test, hopefully, the first assessment, monthly assessment. I mean monthly assessment, not first monthly assessment. So that is on Monday 29th. The topic is gravitational and circular motion. So please get well prepared for that. Okay?
Okay, sir.
Okay. See you then.
Thank you, sir. Bye, sir.
Bye. Okay, yeah, yeah. Allah Hafiz. Allah Hafiz, beta. Zoya and Hanzala, Allah Hafiz.